Hey, and welcome back. Today we're going to continue our discussion on differential equations. You might recall in a previous video we talked about solving differential equations using something called separation of variables. Today we're going to look at some more examples, specifically what happens if we have the u on the bottom, the variable on bottom, and this of course is when we integrate 1 over u, we're going to get that natural log. And this is a little bit more tedious problem to solve for the AP exams. We want to take a look at these. So let's take a look at a very special example to me. There is a very rare element found only at Jordan High School. It's called Wornallium. Um, the rate of decay of Wornallium can be modeled by a differential equation, dy dt equals 1/2 y. Now, for those of you who are familiar with the equation exponential growth and decay, this differential equation right here is really how what scientists use to determine half-life and the age of rocks and other minerals and other elements as well. So we want to solve the differential equation. Given at time equals 0, there is 50 grams of Wornallium. Of course, this is our initial condition right there. So let's go ahead and solve this. So we're going to write this out. We got dy dt equals 1/2 y. We want to separate the variables, but notice there's only a y over here. So I need to bring the y to the left side, and I'm going to bring the dt to the right. Even though there's no t over here, I'm going to use just the 1, but I am going to leave the 1/2. Okay, so let's go and do that. When we do this, we're going to get 1 over y, because I'm dividing by y, dy equals 1/2, and I'm going to multiply by the dt. I don't want to bring the 1/2 over here because in these types of situations, constants kind of make it a little more complex. So our next step is to integrate both sides. So let's go and take a look here. The left side, we're going to get the natural log of the absolute value of y. That power is 1. That's our natural log rule. This is going to equal 1/2 t plus c1. We're integrating with respect to t here. All right, so at this point, we're going to solve for y. So we can get rid of this y, we can get rid of the natural log. So you might recall, well, how do we get rid of natural log? Well, that's called exponentiation. We talked about this in the previous video. We're just going to really, what we call e both sides. Michael Jackson said it best, just e it. E and the natural log, these cancel each other out, and that's going to give us e to the 1/2 t plus c1. Now, at this point, we have to take a look at a very special rule for us in mathematics, a property in mathematics. If we have let me rewrite this. If we have two exponential functions being multiplied by each other, we know we can add the exponents. Well, what we're going to do is we're just going to go backwards instead. If, for example, over here, we have an exponential function and we're adding an exponent that we're adding right here. So what we want to do is we want to write this as two separate exponents. And what we would wind up with is this, the absolute value of y equals e to the 1/2 t times e to the c1. It's this e to the c1 that's really important for us. We can rewrite this as c2. And that's what we have to do, because this is just right here. What we have here is a constant raised to another constant right there. So what we can do is we can just write this as another constant, and that's what we're going to do. What are you going to say? We're going to say, let e to the c1 equal c2. And I'm going to rewrite this up here. I'm going to rewrite that. So we get the absolute value of y equals e to the 1/2 t times c2. Now, I'm going to rearrange this order, make the constant first, and I'm going to get rid of the absolute value of y. So this becomes y equals plus or minus c2 e to the 1/2 t. Now, for those of you who have never seen this before, this is your exponential growth model. And in other words, this is PE to the RT. And what's really neat is you've always worked with this formula in your pre-cal and your algebra 2 class, even your chemistry and physics classes. But for the first time in your life, you were actually able to derive it from scratch. It's kind of a neat little thing that we do. That's what Newton's calculus allowed us to do in this case. All right, but let's go ahead and continue here. Now we're not done. We need to solve for C2. So we're going to find C2 using the initial condition when t is 0. We know y, which is a Bernaulium, I guess in this case, would be 50. So I can solve it, plugging it in. Now, again, just like yesterday, though, notice we have two choices. We have the positive, we have the negative, but my y value here is positive, so we're going to pick the positive note. So we can say y is positive here. So I only want the positive one. So I plug in, y is 50. We want the positive, not the plus or minus, I just said the positive. We want the positive C2, and this becomes e to the 1/2 times 0, and that's just 1. So we get 50 equals C2. So therefore, our equation would be y equals 50 e to the 1/2 t. And there we have, there's our equation right there. All right, so let's take a look at another example real quick. Number 2. All right, so for number 2, the first thing we're going to do is we got this dy dx equals x times 1 minus y. We're going to divide by this 1 minus y. So we get this 1 over 1 minus y dy equals x dx. And I'm going to integrate. All right, this is a little bit trickier here. So I'm going to switch colors here. So for the first one, this is going to be a natural log, but you'll be careful for the inside. Our u is this 1 minus y. So du equals negative dy. So that's important for us. So we got dy equals this negative du. When I rewrite my integral, oops, missed it. When we rewrite our integral, we would get negative 1 over u du, and that becomes negative natural log, and we already know that that's just 1 minus y right there. Oh, that took a lot of work. Equals, and now we got to do this one, x squared over 2 plus c1. So let's take a look here. So now you might be curious again why we don't put a plus c, a constant on this side. Well, we have a constant over here, so we don't need the 1. So we would just add this, bring this constant over and just become another constant. So we're okay just leaving this one constant. All right, so first things first, oh man, I don't like that negative. I'm going to get rid of that negative right there. I'm going to divide everything by negative. So I get the natural log of 1 minus y equals x squared over 2. Now, what's really kind of interesting here, I could put minus c1, but it's just a constant, so I'm just going to put it as a plus c2. I'm just going to change it. So remember, all I did was divide by negative 1 right there. This just stays, this constant just becomes c2. All right, then we're going to do that exponentiation step. So we got to solve for the natural log, so we're going to e both sides right there. And that's going to give us our absolute value of 1 minus y equals, now, this is the algebra step that's really important. We are adding exponents here. So we can write this as 2 exponents instead. I can write this as e to the x squared over 2 times e to the c2. And this is what I want. So we're going to say, let e to the c1 equals c2. Just real quick, you want to have that. And I'm going to rewrite this. I'm going to get 1 minus y, absolute value, equals, I'm going to put the c2 front, e to the x squared over 2. There's my general form. Now, I am going to solve this, so I'm going to get rid of the absolute value. So let's get rid of the absolute value. We would get 1 minus y equals plus or minus c2 e to the x squared over 2 right there. And again, looking at that's really it right there. It's not really giving us me initial conditions. I guess the one thing I could do, I could solve for y if you wanted to. You get y equals plus or minus c2 e to the x squared over 2, and this will become plus 1. Remember, it's really it's really a minus 1 because I'm dividing by, but I have to divide by that negative. The plus or minus, if I divide by negative 1, it's still plus or minus. So let's take a look at number 3. Oh no, number 3, it has this y prime. Y prime is e, that's just dy dx. So we'll just say this is dy dx times 1 plus x squared minus or equals 2xy. So I'm gonna bring my 1 minus x squared to the other side. So I get dy dx, that's going to equal 2xy over 1 plus x squared. All right, now I'm going to separate my variables. The only thing I want to go over on the left side, though, is the y. Just the y. Everything else has an x on it. Just the y to the other side. And when we divide by the y, we get 1 over y dy. Now, don't forget, we're going to multiply by that dx. So we get 2x over 1 plus x squared dx. Oh, that was hard. Now we're ready to integrate. So we get this natural log of y equals, but over here, we have a u substitution. So we know u is going to be 1 plus x squared. Du is 2x. Oh, that's nice. So we get dx is du over 2x. And if I were to substitute in, we would get 2x over u du over 2x. Oh, how nice. The x's cancel out. So we get the natural log of y. And if I were to integrate this one, we just get the natural log of u, which is 1 plus absolute natural log of 1 plus x squared. Sorry about that. Plus c1. All right. Oh, want to look at natural log on both sides? It doesn't really matter. We still have to solve for y, so we're going to exponentiate both sides. We get the absolute value of y equals, and again, I'm going to write this as a product. We're going to get e to the natural log of 1 plus x squared times e to the c1. That's our little algebra trick. And then we're going to say just let e to the c1 equal c2. Right, so now I can actually just solve for y. I'm going to go ahead and do two steps at once, and this is okay. Y would become, remember we're taking the absolute value both sides, so we get plus or minus, and this becomes, put my c2 in the front, c2, and what happens with the natural log if we take the natural log of 1 plus x squared? Well, the natural log just cancel out, and what we're left with is the absolute value of 1 plus x squared. And we can get rid of the absolute value if we want to, because we already got the plus or minus out here, so we can just leave it as c2 times 1 plus x squared, plus or minus that. And there is our answer. All right, so I hope you enjoyed the video. Please go to video number 2, and we'll take a look at some more examples.